Hello, PreCalc. This is the Tuesday edition, 9/27, so you'll be watching that sometime after our class on Tuesday the 27th, and we're just going to do a few review problems for Wednesday's test. So let's focus on that tonight. We'll play a game. It's called pause points. When I say pause point, you hit the video pause button, you do the problem, and then you rejoin to see how you did. So let me see tomorrow what you were able to do correctly on your own. Number one, I'm going to take a value, 4 pi over 3, it's an angle, and I want to know what quadrant that falls in. So how would I figure that out? Well, normally when I'm looking at my unit circle, I'm going to either work in fourths or sixths. Since this is in thirds, I can quickly change it to sixths and count my way around the unit circle and find where it is. So pause point, find out what quadrant it's in. Alright, back from your work. Let's see. I'm going to change this to sixths by multiplying by 2 over 2, I get 28 pi over 6. Putting in my sixths of pi, remember 6 go above the 1/2 of a pizza and 6 go below the bottom half, and so I have actually 12. When I say I'm using sixths, I'm remembering that this is pi, and I'm dividing pi, which is half a circle, into sixths. So the whole circle ends up being in twelfths. But I'm going to start here, that's 0, and I'm going to count 28 sixths. I haven't drawn in the quarters, so I'm not confused by those. 0, 1, 2, 3, so I'm 1 6 pi, 2 6 pi, 3 6 pi, 4, 5, 6 6, 7, 8, 9, 10, 6 pi, 11, 12, 6 pi, 13, 14, 15, 6 pi, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 6 pi. Did you end up over here? And since the question was what quadrant was that value in, that angle, it turns out my quadrants there are 4 quadrants. This is 1, 2, 3, and 4. So we are in quadrant 2. Alright, let me know if you got that right without my help. If you did not, please observe it until you understand why it's in quadrant 2 and be able to do something similar tomorrow. Number 2, let's take pi over 7. We'll take any radian measure, and I want you to find the complement. How many complements does it take before you have reversed say someone says something negative to you? How many complements will it take before you believe that the compliments instead of the negative report? 90 compliments to erase one bad report. So, with that in mind, that's supposed to remind you that compliments has something to do with 90. So see if you can recall how to find the complement. Pause point. Alright, back from pause point number 2, we know that complements add up to 90, or when you're in radian land is pi over 2 radians. So, what will add to pi over 7 to get pi over 2? I find out by subtracting pi over 2 minus pi over 7. I'll be working in 14ths, so that's 7 14ths is the same as 1/2, and that is the same as 2 14ths. So I get 7 pi over 14 minus 2 14, 2 pi over 14. So 7 14ths minus 2 14ths is 5 14ths, which I write as 5 pi over 14. So that is the complement. Alright, let's also stick with pi over 7 and find the supplement. The supplement of Supplement of pi over 7. All right. Plus point. All right, we're back, and I would like you to do the supplement of pi over 7. So the supplements, if complements add up to pi over 2, supplements must add up to pi. So the number that will is 180 degrees. If you're in degrees, the angles that are supplementary will add up to 180. Supplementary angles in radians will add up to pi. So what do I have to add to pi over 7 to get to pi? To find out, I subtract pi minus pi over 7. So I'll work in sevenths. 7/7 pi minus 1/7 pi equals 6/7 pi. 6 pi over 7. So score yourself for those first three. All right. The fourth one I want to do is, we'll do pi over 7 again. Drawing it, pi over 7 is less than pi over 6, so somewhere over here, sort of low. Pi over 7. Pi over 7 is somewhere in the first quadrant. And did that show up? Yeah. So when I'm looking for, on number 4, what I'm looking for is two coterminal angles. One positive and one negative. So to this angle, pi over 7, find two coterminal angles. Pause point. All right. Back we are. To find the positive one, I'm going to go in the positive direction. Coterminal means this terminal side and this initial side, they share. So a coterminal angle has the same initial and same terminal side. In the positive direction, to find that, I start at the same spot and I end at the same spot. I'm going to have to bypass the first turn and go to the second. So I'm going to have to go all the way around one whole time and overlap pi over 7 to get the positive one. This is the positive direction when it comes to angles. So what is that value? Well, I stopped at pi over 7 and then went around another complete circle. So pi over 7 plus 2 pi will give me the positive coterminal angle. 14/7 and 1/7. 15/7 pi is coterminal, and that's the positive answer. Now I want a negative answer as well. So I'm going to go the other way. I'm going to start here, same where the first angle started, and end here, the same place that the first angle ended. So all these angles have the same beginning and end. This time I went in the negative direction. How can I find out how far that blue angle went in the negative direction? Well, one full turn would have been 2 pi, but we stopped pi over 7 short. So we're going to do 2 pi minus pi over 7. And then we'll recall it went in the negative direction. Yep, did I say pause point? Yeah, I think I already did. So, sorry. 2 pi minus pi over 7. So we have 14/7 minus pi over 7. So we get 13/7 pi, or 13 pi over 7. But remember, we went in the negative direction. So those are the two coterminal angles, one that's positive and one that's negative. So hopefully you were able to do well on those. Let me do one more for tonight, and then I'll let you to your own studies because that will probably serve you better. Let's take the angle 300 degrees, number 5. Oh, was there one I skipped? Wait a minute. Yeah, there is. Before I do that one, let's take pi over 7. And that's in radian measure. So I want you to change it to degrees. So we'll do this one in one more. Pause point. All right, back we are. Did you change this radian measure to degrees? You multiply by 180 degrees over pi radians. So the pi's cancel, and I get 180 degrees over 7. So I can leave it like that. That is non-reducible, or I could switch it to decimals, which is 25.7 degrees, round it. So that was number 5. Record if you got it correct or not. Number 6. And the last one for our little review, and that is, I'm going to give you the 300 degrees. I want you to find the sine of 300 using special triangles. You have to know the 2 special triangles for tomorrow, and one of them is like this. If this is my 30, 60, 90, then I have across from the 30 is a 1, across from the right angle is a 2, and across from the 60 is a square root of 3. Those relations hold. Every angle, every triangle with a 30-degree angle is equal to this or proportionate to these. And then 45, 45, 45 is the other special one, and that's 1, 1 square root of 2. And those are, every 45-degree right triangle is proportional, equal or proportional to this one. So, how do I find the sine of 300 using special triangles? First, draw it. So 300 degrees will take us over to here. So right there in the 4th quadrant, 300 degrees. And I'm going to use a special triangle, and I'm going to get that from my reference angle. Recall that we always create a reference angle from the side of the angle to the x-axis. So that's my reference angle, and look at the value of it. If we went all the way around to 360, we did not. We stopped at 300, so inside of this angle must be 60. So here we have a special triangle, a 60, 30, 30, 60, 90. Across from the 30 is a 1, across from the 60 is a square root of 3, and the hypotenuse is a 2. So I learned that the sine of 300 is going to be the same as the sine of its reference angle, except for the SIGN, the plus or minus, which we'll check as our last step. So, pause point, finish it up before I do. Alright, I'm back. I did all the heavy lifting for you on that one. I forgot to pause it. So, we are doing sine of 60, and that is opposite over hypotenuse. And then I have to think, what is sine? All students take calculus, the butterfly effect. And we looked at all the different functions in all the different quadrants. It turned out in quadrant 4, the only one that was positive was cosine. So that means sine, which we're looking for in this problem, is negative. So negative square root of 3 over 2 is the correct answer for that problem using special triangles and reference angles. Alright, hopefully this review is helpful, and I'd just leave you to study whatever you need to and look through your comp book, look over our practice problems and the special paper that folded in half that had problems on one side, answers on the other. Very easy study guide as well. So, looking forward to having you make me proud on this test tomorrow. Till then, big pause point, over and out.